Good day, friends. Welcome back to the channel. It's Given again from TechnoDrive. Today we've got another inverter. It's an Ecco inverter. This inverter, it came from one of the customer. They already tried to fix it, but unfortunately they couldn't get it right. So after they repaired it, they said it burned the transformer. So there's a small transformer that was burning. I'm going to show you just now. And what they did here is to replace the MOSFETs. He mentioned that they replaced these MOSFETs and also the IGBTs. But after doing that, when they plugged it, it had a smoke. So the transformer, see that little transformer there was burning. So I'm going to explain the function of this transformer and the reason why it burns out. But for me to explain, let's take out the board, and then we can see where it got damaged and what needs to be done. So this inverter, it's a 3.5 kilowatt. It's a Ecco inverter. Let's check there. You can see the model number. It's a Ecco HIN3500. So it's 3.5 kilowatt. Okay, we've got the board out. Let's check and see the transformer. Yeah, you can see this transformer is bent. There's a damage on the transformer. So if you look at this side here, you can see the bend mark. The plastic was melting there. So this transformer is bent. Okay, so let me explain to you why do we have this transformer and the reason for it burning. So this transformer, these are the points for the transformer. So on the inverter, you've got the optocouplers. So I'm sure that when this inverter got damaged, the optocouplers got affected. So now, once the optocouplers have got the short circuit, obviously this transformer is there to supply power to the optocouplers. So you remember the IGBTs, they work, when the IGBTs is on, we should get like 15 volts on on these 2 points there, which is the drain, the gate and the emitter. So on the IGBT, you've got the gate, the collector and the emitter. So on these 2 points, which is the gate and the emitter, you should get 15 volts when the inverter, it's the IGBT is on. So where do you get that 15 volts? We get it from this transformer. So this transformer, it gets power from where? From this big switch mode power supply. So this is the big switch mode power supply. So it supply voltage to the small transformer there. So we can also trace to see if the Zener diodes, because you've got Zener diodes as well. So these Zener diodes, they sometimes fail. So we need to also check if the Zener diodes are still okay. Okay, we've replaced the components. We've just replaced the IC and the resistor there. Let's switch it on and see what's happening. I've got the LCD here. Let's just put something here so that we don't short it. Let's connect power. Okay, the inverter is now switching on. So this is the IC that we've changed. There is the new one, but we're still having error 09. So we are still having that error 09. We still have to look further and see what could be causing this 09. But I'm 100% sure the problem is on the circuit here, because that's the startup circuit. Let's check because they've already worked on this inverter. We have to check like everything to make sure that there's nothing that's not right. Let's check the transformer to see if it's okay. There should be a resistance between this pin and this one. We've got 0 ohm, it's okay. So that is the winding inside. And see here, we should be getting a very low resistance, because this pin is a resistor. There's a big resistor there. Let's check this side. Let me turn the board. Okay, I've turned the board. See this resistor here? This is the one that supplies the power. This is actually the shunt resistor. It's actually for checking the current that the switch mode power supply is working on, so that the IC can control the current. And also, if there's a short circuit, the IC will cut. Let's check. So these are the 2 points for the resistor. Let's check the resistance. It's 33 ohm. So 33 ohm, it's a bit high. I'm sure when they changed this resistor, I'm sure they didn't use the right value, because 33 ohm is not a good. The IC will sense a high current and then it will cut. So 33 ohm is too high. Let's check. I'm going to check on another board to see what resistor they use there normally. Then we can use the same value. Let me take another board. Okay, I've got another inverter. You can see this is the big resistor. This is the one that it's similar to the other side. I'm going to take it out and then we can see what value we are reading on this resistor, and then we can use the similar value on that board. Okay, here's the resistor that I took out from the other board. I'm sure this can't be 33 ohm, because 33 ohm is too high. Let's check the resistance. From what I know, see here we're getting 0.8 ohms. So 0.8 ohms is good for the shunt resistor. 33 ohm, it's too high. Let's check that. Let's change that resistor, and then we can test it again. I'm going to take it out and put another resistor, and then we can see. Okay, I've changed the shunt resistor. Let's check the value now. So we're getting a 1 ohm, which is okay. And there's no short. Let's switch it on again. There we go. Happy, the inverter is now fixed. We've got 230 out. We've got 230. So the inverter is now healthy. We are done with the repairs. I'm just gonna test all other things, but the main thing was to get this inverter to give an output, which is what we are getting now. You can see we've got 230 out. There's 230. Let's just measure with the multimeter. But the inverter is running now. Let's check the output. Okay, there we go. These 2 points are our output. We've got 230, same as what we are reading on the display there. See, with 26 volt, the voltage is right. So we are done with this repair. Thank you very much for watching. I'm sure it's gonna help you.